Hi, this video is one of a series of videos meant to teach the basics of functions. In particular, we're going to look at when you're given a table of values or when you're given a graph. How do you know if you're even dealing with a function? To get very far with this, we should probably start with what a function is. Basically, it's a rule that assigns exactly one output to each input. So, in this case, when I put in a 2, I should just get a particular number out. I got a 2. When I put in a 3, I get a 5. When I put in a 7, I get a 5. A 9 brings me a 0, and 11 brings me a 4. You don't even need to know what rule produced these ordered pairs. I will say this much. Some students think a repetition of y is a problem and would rule it out from being a function. Some people think that when you put in a certain value, you shouldn't get the same value out. But just to illustrate why this is okay, let's pretend x represents a certain house number on a particular road, and y represents the number of children under 18 that live in that house. So this means house number 2 has 2 children that live in that house. Certainly makes sense, you could have that. You have house number 3, 5 children live there. Is it possible for a different house number 7, to also have 5 children? No problem at all. Is it possible for house number 9 to have no children there? Certainly that's possible. And 11 produces 4. So this one, no matter what I put in, it just pairs that number with one particular output. So this one is a function. My abbreviation for function is Fn. So it is a function. Basically, anytime all the x's are unique, it's going to be a function. Looking over here, I'm noticing that I have the number 4 occurring more than once. One time the 4 is paired with 22, and one time the 4 is paired with a different number, 17. That is a problem. So this one here is not a function. And the reason is because if I put in a 4, it should only produce one particular value, exactly one output. But in this case, the number 4 puts out gets paired with 2 different numbers. Just to illustrate this, let's assume that this is 5 players on a basketball team. And I ask you this is their jersey number, that's how many points they scored last month. Can I ask you, how many did number 4 score last month? They scored 22 points. 11 scored 51. Is it fine that number 12 scored the same amount as number 11 did? Sure, that can happen. Is it possible that this jersey number 13 scored 13 points last month? It's possible, but so sometimes the input and the output might match. That's not an issue. But here is where the issue is. Earlier I had said player number 4 scored 22 points, and here I'm suggesting that they scored 17 points. Well, which is it? So that's the problem here. When 4 gets put into a function, it should always yield the same output, but in this case, it did not give me exactly one output. It gave me multiple outputs. So this is not a function. Notice these numbers are the same as these were over here with one exception. This is like me asking you, player 4, how many points did he get? 22. Player 11 got 51. Player 12 got 51 last month. Player 13 got 13. How many did player 4 get? 22. That doesn't contradict what I had said earlier. I had said player 4 got 22, and here it's pairing the number 4 with the same number as it did before. That's just me being forgetful and asking the same question twice. And then 14 got 100. So there's no problem here that the 4 is duplicated, so long as it always pairs 4 with the same value. So this one is a function. Okay, because it did only pair 4 with the same output twice. So basically is kind of a summary of these ordered pairs. If every x is different from itself, automatically it's a function. If any x's are repeated, make sure that they give it the same y every time. In this case it didn't, so it was not a function. In this case, the 4 is listed twice, but it's continually assigning 4 to 22, so that's not a problem, it would be a function. Now let's look at the graphical form that you might be given. I look at this graph here. I'm going to actually start with a graph from E. If I draw a vertical line, you can assume that that's vertical. My vertical line, sometimes the marker skids. Basically, do you see, because I drew a vertical line, that all of these points seem about the same distance over? So that maybe 1 unit over perhaps. We don't know how far over, but because I align them vertically, they all have the same x coordinate. We'll pretend that this is 1 unit over. All of these have a 1 comma something. But clearly the y value is different for all of these. So maybe this is a -2. Maybe this is a 1/2. Maybe this is a 2. But basically they're different heights, so we know these numbers are different. That's a problem. If I have that input paired with multiple outputs, it's breaking that definition that says there should be exactly one output for any particular input. So basically what I've done is I drew a vertical line that cuts the graph more than once. That's called the vertical line test. And I abbreviate that VLT. And when I can draw a vertical line that intersects a graph more than once, it tells me that I'm not dealing with a function. So we would say that this is not a function. And if somebody asked you why, you'd say it fails the vertical line test. Now let's look at the graph in D. If you see the graph, this is meant to continue outward a little bit. No matter where I could draw a vertical line, anywhere I could put a vertical line, it's never going to cut this graph more than once. So this one would be a function. And it's because it passes the vertical line test. So if you can't see any place that you could situate a vertical line so that it would cut more than once, it automatically is a function. I come over here, and you see these graphs have multiple parts to them. A graph can have more than one piece. It can have holes. These are some of the more advanced graphs that you could see later on down the road. So basically, this is the graph, and that's also part of the graph, and that is a big open circle, which is indicating that all of these points here exist, but that point right there is not there. It's missing. But there is a point that I meant to line up vertically with it. So just take it on faith that some of these weird graphs can exist for now. But anywhere I draw a vertical line, this is the most suspect area right here. If I draw a vertical line right here, it's really only intersecting the graph once because it's coming through that point, but it's going through a hole there, which is the absence of a point. So it's only catching one point of the graph. So this one here is a function, and it's because it passes the vertical line test. Let's take a look at H. H, I've drawn the graph, and there's a part here, and there's a part here. And if I draw my vertical line right here through this suspended point, it doesn't look too vertical, but you can use your imagination. Can you see that it cut the graph here and I cut the graph here, unlike over here, there's no hole there, so there's actually a point of the graph there. And when I draw my vertical line there, I capture both of those points, but I'm supposed to only have one output for every input. And that would give me two outputs for this x coordinate. So this one is not a function, and it fails the vertical line test, meaning that it's possible to draw a vertical line that intersects more than once. Finally, on my overcrowded board here, I've got F. Let's take a look at F. Here's a piece and here's a piece, and you might think, oh, everything is fine because there's a hole in the graph, and then there's a point up here. But the problem is, so it isn't going to fail the vertical line test right here because that is a hole. But do you see how part of the graph here overlaps part of the graph here? If I draw my vertical line somewhere over here, I am capturing this point on the graph, and I'm capturing this point on the graph. And since I can cut it more than once, we would say not a function, because it fails the vertical line test. So that gives you an idea of how to answer this question when you're given either ordered pairs or a graph. Thank you. I hope this was helpful.